In this sub-lesson, we are going to learn about the fundamentals of ACI contracts and microsegmentation. How contracts and microsegmentation can be used to implement security within the ACI fabric. When we talk about contracts, the first question arises, why do we need contracts? Let's talk about the holistic view within the ACI fabric on how the endpoints are defined or where they exist within the ACI fabric. The endpoints are part of the endpoint group. An endpoint group contains multiple endpoints which can be VMs, virtual machines, or bare metal servers, all grouped under the one roof. And there can be multiple endpoint groups within a single tenant. Now, by default, an EPG cannot communicate with another EPG within a tenant. In order for the communication to happen successfully, the endpoint group needs contracts. The contracts are used to define relationships. That means it is going to define how one EPG or if an EPG can communicate with another EPG. All endpoints in endpoint group have the same security posture. Now, granular access in Fabric can be achieved natively by breaking EPGs so that all VM endpoints can have the exact same security posture. But with contracts, you only define relationship from EPG to EPG. There are different components that function within a contract. The contract specifies the subject, scope, and description for the relationship. The EPG specifies which contract to consume or to provide. The filter specifies the filter entries which contains the layer 4 information such as the protocols and ports on how they are going to communicate. Subject specifies the filters, direction if the communication is going to be unidirectional or bidirectional between the EPGs. Action, the action to be taken on the filtered traffic with a subject. Label, it's an optional value that you can set. The labels are allowed for more complex definition of relationships within the policy model. Let's now take a look at how subjects look like. Now we have an EPG. An EPG will be containing multiple subjects. Now the subject has multiple filters, action, and label. The filter will have the definition of the input and output port or the ingress or egress port, etc. Action will have, do we need to drop the traffic, do we need to mark the traffic or redirect the traffic? And label field, it's an optional value if you want to assign a label or not. Now contracts can be either consumed or provided. Provided means the destination and consumed means the source. The EPG consuming the contract can connect to the EPG providing the contract. When defining contracts, the contracts between EPGs can be looked at as applying ACLs between a source and destination. For instance, when applying a contract between EPG, we have permit filter protocol, consuming EPG, which is the source, provided EPG, which is the destination, and the destination filter port. We'll now take a look at application communication on how it can be defined as who is allowed to talk to whom. Let's assume a users group which can interact with the web forms. The web forms are the place where the front-end user applications are being hosted, which are accessible via the web. So users interact with the web forms. The web forms interact with the application servers, which define the logic for the applications. And the application servers in turn interact with the DB farm. The DB farm is where the data is stored or used by the app servers. The communication between objects on a network can be thought of as one or two-way conversation. It can be a monologue or a dialogue. In this case, when talking about a web application, it is usually a dialogue. A request is sent, a response is received. Let's now take a look at the provider-consumer relationship. In the same application, we have the users who consume the services. So the web form is the provider and users are the consumers. Similarly, the web form uses the services provided by the app servers. So the web form consumes the app services and the app servers provide the app services to the consumers, which is the web form. Now this relationship can be looked at as the DB form is a provider and app server is the consumer. App server is the provider for the web form and web form is the consumer. The web form is the provider and the user is the consumer. So the relationship is defined end to end on how the communication will actually happen. Using these contracts, more complex relationships can be defined across EPGs hosting different applications. So you have the outside user trying to connect the web to the app and app to the DB. Similarly, through a DMZ zone, we have web to the app, app to the DB. And we can have a different or common services which can be used by both these layers. And we can define complex relationships between both these layers to help them avail the services, such as the DHCP for spinning up new VMs and assigning them addresses, or the AD values for the Active Directory services or the DNS services, which can be used by the web or the database servers or even the app servers. So there are common EPGs which can be used or consumed by multiple EPGs, and the common EPGs will be the providers. Let's now talk about microsegmentation. Now, ACI microsegmentation enables you to automatically assign endpoints to the endpoint groups. Remember, in ACI, the perimeter security is not enough. Once the perimeter security is breached, a lateral movement can allow attackers to compromise more assets within the fabric. So microsegmentation at that point can be brought into play, as it can help improve the security posture inside the data center. Microsegmentation can minimize the segment size and provide lesser exposure for lateral movement. Now, you can implement microsegmentation for virtual endpoints which are spread across Cisco ACI Virtual Edge, or which are part of the AVS Application Virtual Switch, or Microsoft Hyper-V Virtual Switch, or even VMware vSphere Distributed Virtual Switch. So it can be implemented for any of these virtual endpoints. We'll now take a look at a use case for microsegmentation. Let's assume that we have all the different servers or services hosted which are part of the same subnet. So 192.168.10.0/24, let's say. And we have the web form or the web application services being hosted on the IP addresses, say 192.168.10.10 to 10.12. And the app servers are running from 10.13 to 10.15. And 10.16 to 10.20 is where we have the database form. Now, usually we are allowing the communication to happen from web form to app servers and from app servers to DB form. But if we want to, and we want to block the communication from web form to DB form, this is a common use case for microsegmentation. It's really helpful when you have the different services being hosted as part of the same subnet itself, and you want to implement more granularity of the permissions for communication between those servers. Microsegmentations has few key functions. First, you define the endpoint identity. When defining the endpoint identity, we are classifying the endpoints into groups. The groups can be a network identity, or using the metadata or DNS, or even the user authentication for the endpoints. The policy definition, we define the policy to be used between the groups. Like if there is an application dependency, like for web, has to be connecting or communicating with the middle layer app servers. So the app dependency has to be defined, and it can be done using the policy definition. Then we need to make sure that we are verifying the policy enforcement. For policy enforcement, we need to look at the policy visibility, and we need to make sure we are logging the events and the alerts if necessary, if the policy is being breached or an unwanted communication is happening. And once the policy enforcement is done, we also need to look for the lifecycle management. Why is this important? Lifecycle management is important because the policy enforcement, over the period of time, over the period of deployment, you will be learning more and more about your network and your applications and the policies. And the more you learn about them, you want to keep updating your policies to make sure that they are up to date and there's no security breach coming into play. So constant updates are required for lifecycle management. We'll now talk about attributes and enforcement points. Now, within the ACI fabric, there are different attributes that are required for microsegmentation. One is the network-based, in which we define the IP and the MAC information, and the VM-based, which define different sets of information such as the VMM domain, guest operating system, hypervisor, or VM name, VNIC, and attributes and tags. So we can define a whole lot of information with the VM-based attributes. Now remember, the attributes must be unique within a tenant. Why? Say for you're defining a network-based attribute and you're defining it for a particular IP. You cannot apply the same IP again and again. You need to apply, if you want to apply the attribute, a different attribute, you need to define it with a different IP. Say for 192.168.1.1, you cannot have a different policy attribute with the same IP address. You need to have a different network-based attribute with a different IP address. Enforcement points are where we can apply the microsegmentation. It can be at the host level or host-based, or it can be at the network level or network-based. So for host-based is used for centrally managing the host-based firewalls to implement the security. And for network-based, we are centrally managing the access rules at the network edge. That means either at the virtual switch level, the physical switch level, or at both levels. So these are the fundamentals of contracts and microsegmentation.